Hi, Assalamualaikum warahmatullahi wabarakatuh and good evening to Dr. Hafiz. Okay, today I'm gonna present about my mini project by using a AWS Sandbox environment, which is construct a back-end online voting system for a television talent competition. So my name is Zahidah Binti Suhaimi and my metric number is 2313200510. Okay, this is the overview that I want to present today, which is the first one is introduction, objective, architecture diagram, AWS cloud survey that used in this mini project using the sandbox environment, result and step, problem and discussion and conclusion for this mini project. Alright, we go to the next slide, which is we go first to the introduction of this mini project. Okay, developing an efficient and trustworthy online voting system is important in the modern era of advanced challenge technologies, especially when there are significant stakes involved, such in a talent competition that is seen on the television. This mini project explores the complexities of building a reliable internet-based voting system architecture within the limitation of the AWS Sandbox environment. The back-end online voting system has been developed with scalability, cost effectiveness, operational efficiency, and the security in consideration. Okay, it has been constructed using a multiple of AWS cloud service. Okay, next we go to the objectives of this whole of mini project. I have four of objectives. The first one is to ensure that the system can handle concurrent of voting activities without the compromising data integrity. The second one, they dynamically change the number of back-end instances of in responding to demand, optimize the auto-scaling. Next, to utilize amazing RDS snapshot, which is schedule frequent database backup. And the last objective in this mini project is to identify the address performance issue, which is set up the monitoring of Amazon CloudWatch. Okay, the architecture of diagram of this mini project backend online voting system is as we know that an architecture diagram is a graphical represent of a system or application that we use that is component, linkage, and in structures such as a server, database, user interface, and a network connection. To construct a back-end voting system, which is that I want to construct now, is a very important element and feature of an online voting system back-end with the AWS cloud service. The most important element and feature of an online voting system backend with the AWS cloud service today is I have 6 of AWS that I use in the project. Which is the first one is network control, which is we using the AWS Visual Private Cloud, which is a VPC. The second, for the data storage, we use the Amazon RDS MySQL. Security measure, we use the security group. And the availability and scalability, we use the Amazon ELB or Elastic Load Balancing. Web server, which is the backend of web server, we use the auto scaling and Amazon EC2 instance. And the last one is to monitor the server, we use the Amazon CloudWatch. Okay, these 6 of Amazon that we use that have been applied in this backend all over the system by using the sandbox environment. Okay, we have several of steps and result to complete this mini project using the sandbox environment. Alright, we go to the step 1, which is we need to start the sandbox environment to access the AWS Management Console, which is we see the Start Lab button. We go to here. Start Lab button in here. When we click the Start Lab, we look at the pop-up window that will display the message of lab status ready. Like I have this figure. Okay, next. After we go to the AWS website, we need to create a virtual private cloud, which is VPC. Okay, why we need VPC in constructing a back end of one of system that we need to develop? Okay, employing the VPC in this online voting system allow the construct a private isolate network within the AWS cloud. Okay, the system may simply add or delete instance, database or other component based on the online voting system demand without the impacting the rest of the infrastructure. Okay, as we can see here, this is the VPC that I have been created using the dashboard that have been given. Alright, next we go to step 3, which is create an additional subnet. Okay, as we can see here on the left on navigation pane, click on the subnet link and then click the create subnet button to create an additional subnet within the VPC. Okay, why adding a new subnet is important in some system? Okay, adding subnet to the VPC for online voting system on AWS can provide a various of benefit in terms of organization, security and resources of management. Okay, construct two more subnet for the VPC in a second availability zone in this step. Subnet in various availability zone inside a VPC are important for establishing a high availability system. Alright, in this next step, in this mini project, I have created a VPC security group. In this part, construct a VPC group that will operate as a visual firewall in this online voting system. Each security group can have rules added to it that enable traffic to or from its related instance. Each component in this voting system, I have include a web server and database that may be assigned to a distant security group. Okay, in this VCP security group, I have created two of database, which is the first one is for web server that I use a HTTP IPv4. Okay, we can see in this first picture, this one, and then the second one I have created a database for security group that I have used a MySQL Aurora, which is this figure. Okay, we go to the next step. Okay, the next step is will be construct a DB subnet group, which is used to notify RDS which subnet may be utilized for the database. Each DB subnet group require a subnet in at least 2 availability zone. Okay, this database subnet group is very important for improving the network performance, increasing security, and assuring high availability and fault tolerance in an online voting system. Every database in a subnet group should have subnet in, at least 2 availability zones within the AWS region. This enables high level of availability and redundancy support for database increase. As we can see here, I have select two of subnet in this data information. Yes, I have select two subnet associated with the CIDRH 10.10, 128 and 130 that I have shown here. We go to the next step. Okay, the step 6 is I have created an Amazon Relational Database Service, which is the RDS instance, for an AWS host online voting system, which is Amazon RDS, provide an automatic database backup on a daily basis with the option to save the backup data for a chosen time duration. This aids with data recovery and guarantee that the online voting system can be swiftly return to its pure condition in the event of unintentional data loss or corruption. Okay, besides from that, AWS provide a pay-as-you-go pricing mechanism for RDS, which is allow the user to optimize cost based on the real usage that we use. Okay, in this step, I have choose the engine option. I just choose MySQL, and the important thing is I have configure the connectivity of VPC Zahidah mini project that I have developed just the previous step just now, and connect to the DB subnet group database of mini project. In this database of instance, I have chosen DB security group Zahidah mini project that have developed the previous step, which is the for the web server and the for database. But in this step, I will choose the database security group. Okay, in this step, we have to disable the backup because to can speed up the database deployment for this experiment or mini project. Okay, next we go to the most important step in this mini project, which is launch the first web server instance. Okay, what is the function of instance through the Amazon Elastic Compute Cloud, which is EC2? Okay, the first web server instance is launched, allowing for a basic scalability testing of the system. It can determine the program efficiency and responsiveness, guarantee that it can manage the predict user traffic during the peak voting period. In this case, AWS CloudWatch may monitor the performance of the web server instance. Yes, okay. The CloudWatch can set up an alert or for essential indicator including the CPU, network activity, and this input and output to handle the problem before arrest and optimize the resource consumption. Okay, we can see here, I have named the launch instance, which is the server voting system, and we can see this the summary of this step, which is I have choose the Amazon Linux 2023, which is ARMY, and I have connect the instance with the firewall that I have created previous step, which is the web security group that I has used the HTTP IPv4. Okay. Okay, next we go to the create ARMY for auto scaling through the instance of EC2. During this procedure, I have created an ARMY, which is the Amazon machine image from the existing of server online voting system that I have been created previous step in here. The step is I have include here, and this will save the content of the boot disk so that the subsequent instance may be launched with the identical content. To launch the new instance, auto-scaling for ARMY will be used in this mini project. When auto-scaling launch a new instance, it uses this ARMY to ensure the consistency in the deployment of the online voting system component. This can reduce the variation in configuration and ensure that each instance begins with the same baseline. Next, okay, after we create an ARMY for the auto scaling through the instance of EC2, we have created a load balancer in this mini project. Okay, in this section, I have created a load balancer which that can balance the traffic across the multiple EC2 instance and the availability zone. Okay, developing a load balancer is an important step to improve the scalability, availability, and dependability of the online voting system using AWS. Okay, the load balancer can check the health of instance. If an instance becomes unhealthy or unresponsive, the load balancer automatically sends the traffic to the health instance, and increase the online voting system overall the fault tolerance. Okay, this is the step that I have been create the load balancer. Okay, after create the load balancer, we will go to the create a launch template. Okay, set the launch template configure for instance by supplying information such as the army, a key pair, instant type, security group, and a block device mapping. The launch template play an important role in an AWS-based online voting system for establishing the consistency, efficiency, and management in EC2 instant deployment and scaling. Okay. As we can see here, in this tab, the detailed CloudWatch monitoring, I have enabled this tab because of to closely monitoring the metrics such as the CPU usage for the web server, memory usage, and the network activity at 1 minute that the web server is being used. Okay, next. Okay, we create an auto scaling group. Okay, why we need to auto scaling group in this mini project? As we know, the auto scaling group manage the increase or decrease of the Amazon EC2 instance based on a demand to ensure that the online voting system can handle the variable of workload or efficiently. Okay, this dynamic scalability guarantee that there will be enough instance to manage the increasing traffic during the peak voting session while also allowing the resources of optimization during the low activities phase. Okay, after we create a load balancing, we need to verify the load balancing, which is it is the load balancing is working or not. Okay, the purpose of this task is to confirm that load balancing is operating as intended. Verifying whether load balancing works efficiently in an online voting system is the most important to make sure the system are stability, availability, and performance. Okay, now this is the one of most challenge in my mini project, but there will be a the solution for this problem. Okay, I will be make some discussion in this challenge to the next slide. Okay, we go to the next step first. Okay, the step 13 in this mini project, we go to the test auto scaling after we create a load balancer, auto scaling, and more. Okay, why we need to test the auto scaling? Okay, as we know, the testing auto scaling with AWS CloudWatch is an important step in confirming the efficiency, dependability, and responsive of the scaling mechanism in an online voting system. It can identification and resolution of possible issue to make sure that the system can efficiently adapt to changing workload while maintaining the peak availability and performance. Other than that, testing allow in determine the efficiency of the scaling triggered such as the CPU, network activity, and custom CloudWatch metric. This guarantee that the auto-scaling group react the correctly of variation in demand and adjust the capacity of the online voting system. Okay, as we can see here, there will be two alarm that I have illustrated in this figure, which is you can see here this one and this two. Okay, I hope you can see it. Okay, the auto scaling group generate them automatic and they will automatic adhere to the 2 to 9 instant limit while the maintaining an average CPU load of roughly about 16%. Okay, we can see here. Okay, then the CPU load will reach 100%, at which point check the load test. The load test will procedure after it reach its peak. After 5 minutes of waiting with the AWS CloudWatch, which is when the console open, the alarm low alert will now read okay. Okay, we can see here. In this yellow highlight, the alarm low will read now okay, and the alarm high will change to in alarm as seen in this figure. Okay, the red highlight is for the in alarm. Okay, those alarm will be changed every 60 seconds or 1 minute. To update the display, you can choose the refresh icon in the top right of this red highlight. And once it reaches its peak, the load test will trigger the process, and the alarm high can be seen, which enable the CPU will be high. Okay. Next. Okay, after we test the auto scaling, we must monitor the instance, which is the web server of online voting system. Monitor is a widely recognized as an important element for make sure the performance, health and stability of the infrastructure in an online voting system. Monitor make it possible to keep track the importance of operational parameter, including the CPU, memory use, disk input and output, and network activity. Okay. As you can be seen here, I have monitored my instance server online voting system. Okay, how to monitor the instance, which is we can select the online voting system, and there will be a monitor tab up here, but I have scrolled down, it cannot see. And then we can monitor this server online voting system instance of Amazon CloudWatch Matric. After that, we need to terminate the server voting system. In this task, I will be shut down the server online voting system. This instance was used to build an army by the auto scaling group, but it's no longer required to use. Okay, as we can see, is terminate and shut down here. Okay, next. Okay, this is the one most of problem in this to develop the mini project. Okay, as you can see in the step 12, which is to verify the load balancing is working or not, it can be observed that since the head state is unhealthy, so the web server from DNS LEB will be changed to back gateway lah. You can see here, and this the unhealthy and unhealthy. Okay, also attribute this to the transition from the voting server army to the Amazon Linux army. The adjustment was very important for the advancement of this mini project, and if had not executed it, then they will not have been able to proceed, which is when I want to construct this mini project. I have stuck in several steps that I need to do this mini project to the step 1. So bila saya try buat untuk LED kot, rasanya dia akan start kepada separuh jalan kerana dia cakap sistem tidak lengkap. Okey, sebab itulah saya berubah kepada Amazon Linux Army, sebab ia adalah sangat important untuk meneruskan web server ini. Okay, however, when we use the Amazon Linux Army, the health status of both freshly generated instance was marked as unhealthy, as seen that I have described just now. But, okay, the problem, there was a problem, but the server can still monitor through the AWS CloudWatch, which is in the step 13. When the testing of the auto-scaling, the DNS lag will be changed to bad gateway, right? However, it can still monitor the server through the CloudWatch AWS. Enable the access the DNS server in order to run the load test. Fortunately, still have the option by continue to manually scale the server with the auto-scaling dynamic policy and monitoring it by using the AWS CloudWatch as seen in this section. Okay, once it's reached its peak, the load test will trigger back the process, which is the CPU utilization of the process. Okay, we can see here, it will trigger back the process. Now, we go to the discussion and conclusion. Okay, this discussion and conclusion is conclude to the all this mini project, which is to construct the back-end server online voting system for the talent television. Okay, this mini project which aim to create an effective online voting system for television talent competition using the Amazon Web Service AWS. There was a phase both of success and several of problems that emphasize the constantly changing character of the cloud-based solution. However, the most significant problem arises when switching from the voting server army to the Amazon Linux army. This has a result in several related difficulties that were insurmountable for the target group. Nevertheless, the various of effort have already been made to try and solve this challenge. As a result, the AWS CloudWatch, we can do a manual configuration, allow for the monitoring and essential parameter and the gain of insight into system performance that enable the proactive management in an environment of impediment. As I strive strive on constructing the on-the-voted system, I have gained a lot of diverse set of experience from both successes and failure, which contribute to a better understanding of AWS service and their application in real-world application. I think that's all from me. Thank you for listening. Thank you, sir. I hope you enjoy.